In this video, I'm going to introduce you to logarithms. And a logarithm is literally an exponent. It's just a different way to write an exponent that we're not used to. So just like if I were to say 0.5 is 1/2, they mean the same thing. They're just written down in two different ways. So I want you to understand and get out of this section that logarithms are exponents. It's just something new that we have to get used to, a different way to write it down. So the definition of a logarithm says if we have a is equal to b to the c, this is what's called exponential form, then we can write down the same thing but using logarithm form. So logarithm form would look like this. We would have log, then you would have your base b, and let me color code this so it matches up. This base b, this b, is going to be the same as this b here. Then we would have a, sometimes you'll see it with parentheses, sometimes without, and that's equal to your exponent, because a logarithm is an exponent. So that's c. So this should be the same c as this. And this a that I take a log of, so that's a function. You plug in an a, you get out your exponent. That a should match with this a. So there's something called a common log. And a common log is when you have base 10. So I would plug in a value for x and I would have a base 10. Sometimes you'll see it written without the 10 and you can assume that there's a 10 there. So if you see no base written there, you can assume it's 10 so that it's a common log. And if you look at your calculator, the common log on your calculator is right to the left of your 7 button. It says log. That is base 10 common log. Then we have the natural log, which is log base e, our irrational number, 2.178, okay? And a lot of times that's written as ln for natural log, and that ln is right next to your 4 button on your calculator to the left. You'll see ln. So above your log button for base 10, you'll see 10 to the x, because that's the exponential form of log, common log. And then you'll see ln for natural log, where e to the x, e is your base for natural log. Okay, so we talked about this. Two very important things to get out of this section. First one, logs are exponents. It's just a different way that we're not used to writing it down, but that's what you have to drill into your head. If I ask you to find a logarithm, you're finding an exponent. The second thing that we're looking for, that logs and exponential functions are inverses. So just like when I square something and then I square root it, they undo each other and they're inverses. Logarithms and exponential functions undo each other and they're inverses. And when we get a little bit further into this section, I'm going to use solving equations and our definition of inverse to prove that to you. But before we jump into that, I need to first help you comfortable here with logarithms. Okay, so in this first table here, I want to get you comfortable with going back and forth between logarithmic form and exponential form. Exponential form is what we're comfortable with and what we've been using all along, but now we're going to put it into log form. So whatever the log is equal to, that should be your exponent. So whenever you're trying to go back and forth between logarithmic form and exponential form, I want you to refer to the definition up here that I just highlighted or boxed in yellow. Okay, so in the first example, in this box, it gives us the logarithmic form. It says log base 5 of s is equal to t. t is what we're setting equal to the log, so t is our exponent. 5 is our base, so I'm going to write this as 5 to the t is equal to s. So this is exponential form. So these two statements are equivalent. We're just writing them two different ways. So it's very different than what we're used to, but it's just something that we've got to practice to get comfortable with. Okay, so the next one also is given in logarithmic form. So a is my base. What we're setting it equal to is b. So b is the exponent. If it says log of something is equal to something, that something on the other side of the equal sign is our exponent, because that's what the log is equal to, and logarithms are exponents. I'm going to say it 100 times in this video to try to pound it into your head so that you get comfortable with it. So I'm going to write a is my base, b is my exponent, and I'm going to set this equal to 12. Okay. The next example is given to us in exponential form. So our base is 4. So I'm going to write this as log base 4. Notice our exponent is s. So I'm going to set it equal to s, and then what goes inside here is t. So when I take the log base 4 of t, I should get s. Okay, 25 to the 1/2, that means the square root of 25, because 1/2 as an exponent is the square root, is equal to 5. 1/2 is the exponent, so I'm going to set log is equal to 1/2. My base is 25, so I'm going to put that down below here as a subscript. And then I'm going to take the log of base 25 of 5, and I'm going to get 1/2. Okay, next example is given in log form, and we need to put it in exponential form. So my base is 4. My exponent is a, because that's what log is equal to. And this is saying 4 to the a is equal to 131. Now going in the other direction, exponential to logs. My base is a, so I'm going to have log with the subscript here for my base a. My exponent is -4, so I'm going to set this equal to -4. And what I'm taking the log of is b. Okay, this next one is a little tricky, something to think about. My base is 2, so I'm going to write this 2 to the power of a, because a is my exponent, and then I set it equal to 0. Now, this is the correct form if we're going from log form to exponential form. However, what makes this tricky is if you look at it, this value of a does not exist. There is nothing that I can raise to the power of 2 that would ever give me 0. If I raise 2 to a positive number, like 2 to the 3rd, 2 to the 4th, that's never going to give me 0. If I raise 2 to the 0 power, that will give me 1. And if I raise 2 to the a negative exponent, that doesn't make it 0. It just makes the fraction flip upside down. So if I had 2 to the -1, that just makes it 1/2. So there is nothing that I can plug in for a that would ever make that statement 0. So even though this is the correct form to write it in, a does not exist in this case. Okay, next example is given to us with the natural log. If you see ln, it's the same thing as saying log base e. So my base is e, my exponent is b, and I'm going to set this equal to a. Okay, now going from exponential to log form. My base is c, so I'm going to have log base c. My exponent is 0, so I'm going to set it equal to 0. And I'm going to plug in 1 for my log. Log base c of 1 is equal to 0. Going from exponential form to log form. My base is 2. My exponent is -3, so I'm going to set it equal to -3. And then what I'm taking the log base 2 of is 1/8. Okay, next one. I take e to the x is equal to a. My base is e, so I can write it as log base e. My exponent is x, so I'm going to set this equal to x, and I'm taking the log base e of a. Now, because this is log base e, another way you can write it is natural log of a is equal to x. Either one is fine. They mean the same thing, just so you're aware. But on your calculator, log base e is shown as ln. Okay, last example. We're going to go from log form to exponential form. So this is also one to think about. My base is 3. My exponent is x, and I'm going to set this equal to -9. This also is a does not exist. There is no value of x for which this will ever happen. If I plug in a positive number for x, 3 to some positive number is certainly going to give me a positive number. For example, 3 squared will give me +9. If I plug in 0 for x, 3 to the 0 is 1. And then if I plug in a negative value for x, such as -2, all that's going to do is square the 3, and that negative in the exponent is going to flip it upside down. So with exponential functions, also remember, another way to look at this too, if you're looking at it graphically, 3 to the x, the graph of 3 to the x looks like this. It's an increasing graph, okay? Never will it ever equal -9 all the way down here. That will never happen. It never reaches -9. The whole graph is always above here. It's always positive. So that's another way you can look at it too graphically.